out the cross-section view. Okay, so if we sketch out the cross-section view, cross-section of member BC. Okay, cross-section, I do apologize. Cross-section of member BC. Okay, we're going to sketch it. So if we sketch the cross-section view of member BC, right? So we know that the cross-section is like this. And we know that this is 1 inch. Right? This is the 1 inch. And over here, this is a 3 inch. And the 1 inch is, if you see how the 1 inch is measured, is parallel to the x-axis. So when that's the case, this axis over here, right, is your x-axis. And then the vertical axis over here, this is your z-axis. And the dot over here, this is your y-axis. Okay. So this is the part that's critical. Why? Because it dependent on how we visualize the buckling, right? So if we want to if we want to analyze buckling about YZ plane, like before, like what I taught you before, right? We know that the P critical is equal to what? Pi squared E, because YZ plane is going to be what? IXX over LE squared, right? Then if we're going to do buckling about the XY axis or XY plane, yeah, XY plane, come on, spell plane properly. If we're going to buckle about XY plane, we know that PCR is equal to pi squared E I ZZ over what? LE squared. Okay. So for this case is a bit more challenging. Why? Because we are not given the values of IXX and IZZ. You have to compute. The previous example, we are given a what? We are given a beautiful table over here, right? If you've got your orientation right, you can get your values of your IXX and IYY, right? For this case over here, what we have, based on the axis that is given to us, we need to identify what is our IXX and IZZ. And I think the previous, last week, I thought you have to identify, right? Okay. So the next thing we are going to focus on buckling. Okay, we're going to focus on buckling. In the YZ plane. So YZ plane, right, is this plane over here, right? If I draw a box down here, this is our YZ plane. Right? And YZ plane, if we were to buckle, right, it will buckle like this. And if you look at the both point B and point C, this is pinned, right? And this is also what? Pinned. Because physically, you can see that there's a pin down there. Okay, and it cannot withstand any moments at all. Okay, so we know that there's pin. So when it is pin, so we know that both ends are pinned. Okay, in the XY plane, we know that it's pin at both ends. So when it's pin at both ends, what will happen? Okay, so if we come to this pin at both ends pins, this is the diagram that you should look at, right? So this is the most important thing, both ends are pinned. So when that's the case, LE is equal to L. Okay, LE is equal to L. So our length over here, right? Our length over here is equal to what? Is equal to square root of 3 times 12, or 3 times 12, so 3 times 12 squared plus by 4 times 12 squared, and then we square root both ends. So 3 times 12 squared plus by 4 times 12 squared, square root. So if 3 times 12 squared plus by 4 times 12 squared, square root is equal A. How come 3? How come I can't get this? No, 3 times 12 squared plus by 4 times 12. Okay, I need a bracket. 3 times 12 squared plus by bracket 4 times 12 squared, and then square root is equal to 60 inches. Okay. So both ends are pinned. So from here, we know our LE is equal to L. So this is 60 inches. So the next thing is our IXX. So XX is the axis of interest. So I will draw this in orange. So XX is the axis of interest. So when this is the case, this is your width. And over here, this is your what? This is your depth. Okay. So IXX, so the width is equal to 1. The depth is equal to 3 cube divided by 12. Okay, so 1, that's by 3 power 3 divided by 12 is equal to 2.25 inches to power of 4. So from here, we can calculate our PCR is equal to pi squared multiplied by 29 times 10 to the power 6. IXX is 2.25 and divide by LE, which is equal to 60 squared. So in the XY plane, the answer is 178.887 times 10 to the power 3 pound force. Okay, that is buckling in the YZ plane. Now, the next thing we're going to do is we're going to look at buckling in the what? In the XZ plane. So buckling in the XZ plane, in the XY plane is going to look like this. Oh, hold on, let me draw properly. It's going to look like this. No bending, then a bend again, no bending. So this is the deformation pattern. Now, why did the deformation pattern look like this? Okay, why is it different? Because if you look at the slot, so this thing, right, to fix into here, you need to have another part attached over here, right? You need another part attached over here like this. Okay, you need another part attached over here, right? So this part attached over here, right? The structure cannot rotate. Yes or no? The structure cannot rotate in this direction or this direction. It's not allowed to go into that direction at all. So when that's the case, you prevent rotation, means you're inducing a moment. So moment is not equal to 0. Likewise, on the side, moment is not equal to 0. Because you need another piece coming in here, yes or no? So it will prevent the rotation. So when that's the case, if now we were to analyze buckling, in the XY plane, right? We know that both ends are fixed because of the resistance, right? Moment is not equal, both moments are not equal to 0. So both ends are fixed. I'll write it out. So both ends are fixed. As moment is not equal to 0. So when that's the case, LE, right? When that's the case, when both ends are fixed, okay, so you could refer to this diagram, both ends fixed. Right, you come over here, you realize that both ends are fixed, right? So you know that LE is equal to 0.5 L. So this is equal to 0.5 multiplied by our L, which is equal to 60. 0.5 times 60, you have 30 inches. So when that's the case, we can calculate our PCR is equal to pi squared multiplied by 29 times 10 to the power 6 and multiply by 2.25. Okay, and then we divide by 30 squared. So this will be equal to shift pi squared. That's by 29 pi over 6 times by 2.25 divided by 30 divided by 30 is equal to shift pi squared times by 29 pi over 6 times by 2. Not 2.25. Why did I get 2.2? I do apologize. Rushing again. Okay, this is wrong. Okay, so now we have to get what? IZZ. I do apologize. So IZZ, I'm going to change the color now. We're going to use green. So this is the ZZ axis of interest, right? So now this is our what? Or ZZ, this is our width. And then this will be our depth. Okay, so for the ZZ axis, our IZZ, so the width is 3, the depth is 1. Okay, the depth is 1 cube divided by 12. So 3 divided by 12 is equal to 0.25. Then from here, our P critical is equal to pi squared times by 29 times 10 to the power 6. Then multiply by 0.25 and then divide by 30 squared. Okay. So when this is the case, so 29 power 6 times by 0.25 divided by 30 divided by 30 divided, then times by pi squared is equal to 79.51 times 10 to the power 3 pound force. Okay. So we have, so the critical load or the allowable critical load, you pick the lower value. Okay. The allowable critical load is equal to what? It's equal to 79.51 times 10 to the power 3 pound force. If you were to select the bigger one, right? If you select 178, right? Our structure will buckle in the what? In the XY plane. So we choose the what? Lower value. So once you have here, you immediately can calculate the critical stress. Okay, why we have to calculate critical stress? I'll explain later. So this is 79.51 times 10 to the power 3. Divide by the cross-sectional area. Okay, so this is basically PCR divided by area. Right? So this is 79.51 times 10 to the power 3. Divide by the area of what? If the area is 3 and 1, okay, the width and the depth. So 79.51 power 3 divided by 3 is equal to 79.51 power 3 divided by 3 divided by 1 is equal to 26.503 times 10 to the power 3 psi. And this is less than the stress yield of what? The yield given to us is what? As I wrote down earlier, 36 times 10 to the power 3. Okay. Now, this calculation is important because if you don't calculate this, okay, no doubt you can withstand the force. However, with the area, right, we have a very small area, the structure might fail. Okay, so this is just to say that the structure will not fail by yielding. Right? We already checked that this is the critical load. So this value over here is the critical load before buckling will occur. Okay. If it's greater, is let's say put 79.52, then buckling will occur. I've not finished this question yet. Okay, I'm going to stop here and I'm going to post the homework tomorrow. You have exactly 1 week to do your homework. Okay, thank you. Thank you for your time.